The presentation is on Conan for LabVIEW, or managing package requirements per project, but I'll explain later why. First of all, our giants are female slide. I chose Margaret Ingalls today because she's related to the new field of interest that I'm working in. She was the first female to graduate from the University of Kentucky and the second woman engineering graduate in the United States. She was a member of the American Society of Heating and Ventilation Engineers, and she worked on air conditioning. She developed a temperature scale for humidity and air movement that includes human comfort. And she also wrote a lot of papers, and one of them is the Petticoats and Slide Rules, and it documents the pioneer American woman of the engineering field. So I chose her because I recently joined Yaga, and we also we produce radiators, and we work on air ventilation stuff. Well, about me, I'm Stefan. I'm located in Belgium, and I work at Yaga Climate Designers. I use LabVIEW since 1999, and I'm a LabVIEW champion since 2021. I also created a leaderboard for the Advent of Code with a Discord server for LabVIEW developers. And you can find me on the NI Forum, Twitter, and I like to play board games. So if anybody likes to play a game, find me over there. A little bit about Yaga. In the past, they were called the Radiator Factory because we produce radiators. But not just radiators, they're pretty smart. They can heat and cool. And the magic is in there's a fan in there. So it needs a dynamic controller to control the speed of the fans, stuff like that. But there's also big vision in Yaga. We have 5 big values: respect nature, and that's very important. Use less energy, be sustainable, awake the artist. Things have to be beautiful. Dream a future. It's also a big issue at the company to be very innovative and try to create new things. Also create emotion. We have an experience lab and a cool lab to experience what we create, and then build bridges between all the stakeholders that install or use our products. So that's why we changed Radiator Factory to Climate Designers. And that guy is actually our CEO. He also wrote a book, Innovate or Die. So it goes about how the industry needs to change and be very innovative in the way to produce things, or nature will make sure humankind will die. That's very goes very far, but if you are into that stuff, I really recommend the book. So, and in being innovative, we should be daredevils, and that matches very well with the topic of today, because my journey into package management was also being a bit of a daredevil and leave the beaten paths. Now, as I said, this presentation was created before I joined Yaga, when I was still working at Intersoft Electronics. And I'm going to use the presentation from there, and I want to give them the recognition and thank them for all the opportunities I had for taking this journey. Now, what's on the agenda for today? First, I'll define what we want. What was our problem we wanted to solve? Then something about handling dependencies in general. something about package management, existing processes, existing package managers, and then about Conan. It was already in the title. I'll explain what it is and how we used it. And I'll end with a summary of pros and cons. So maybe one more thing, a reason to do this presentation, or at least the first one. If you present on Conan, which is an open source package manager, and you do a public presentation, I'm not sure if people can see me, but you get such a hoodie. I can also show it over here, this one. So if nobody gets something out of this presentation, at least I got a hoodie. And so I'll do a short story of the journey that I made in package management, and tell you about my findings and opinions. And at the end, I can do a short demo if there's enough time left. This is not a tutorial on installing or configuring Conan. It's not very hard, but you have to configure a couple of things. If anybody wants to dive deeper into that, I'll be happy to do a one-on-one talk or help you out with getting started. But that goes behind the scope of this presentation. Also, no in-depth behind-the-scenes explanation. Conan has a very good documentation, and as said, I'm always willing to help you out. And I don't have the intention to replace any of the existing package managers. I don't want to throw another package manager into the LabVIEW ecosystem. It was just something that solved our problem and was already used within the company. So what was the problem we were trying to solve? We wanted to have our dependencies per project. That was really the big issue. And that's the question that you have to ask yourself. Is it really necessary that I want all my dependencies inside a project folder? Or is it okay if I install my dependencies system-wide and if all the projects use the same packages and package versions? Then we also wanted those dependencies to be version controlled. Like if a project has a dependency to several packages, we want those dependencies to be those package names and versions in Git, not the packages themselves, but some summary or a file or whatever in Git. We want an easy way to share and deploy them between colleagues, but also with CI systems. We prefer to have the same workflow for all developers, and that's more than just LabVIEW developers. Preferably open source, and of course, if possible, free. Now, dependencies per project. The idea came from Python. You have virtual environments. You install whatever you need within the virtual environment of a project. But in LabVIEW, everything's installed in the user lib, and then all your projects use the same version of a certain package. So that was bothering us a little bit because at Intersoft we had a lot of projects, a lot of different, a lot of legacy code. So some projects just needed all the versions of a package, and then you have to swap them. and downgrade, upgrade if you open a new project. It was a bit of a hassle that we wanted to get rid of. Now, you can always put everything inside the project, but then you have a lot of copies everywhere, and that was not the way we wanted to do it. So you exclude the reuse code from the repo, but you want to include an overview, like for example, a VIPC file or a manifest file or whatever, some overview file that contains which dependencies are needed. And then different projects can have different requirements. As I said, not only different packages need to be installed, but sometimes it's just a different version of a package. Especially if it's an older project that you need to reopen and check something, you want to go back to the package version that was used to build it at that time. So that was a bit the problem that we had and that we tried to solve. Now, one thing that was clear from the beginning is that we wanted to avoid relinking a lot of stuff. If we have a project that uses package A and B, and they both use package C, then now if you, for example, use the VI package manager from JKI, it installs all those packages in the user lib and it nicely relinks them and they all know where to find each other. If we want to do this per project and we have to take care of the relinking, that would also be more complicated. So now let's say we have library C and we create a package from this one. Now we work on A and B and they both use C. So we have a support folder that contains C. Great. Let's package A and B. And then we create a new project. And in the support folder, we need A and B, but they also need C. So now the relative path from C to A and B changed because it's not A/support C, B/support C. It changed. And that's why there needs to be relinking. And the way we solved it is by using project libraries. So every package is built into a PPL. It's a dynamic link library that's precompiled. And they are installed in the support directory, in the support folder, next to each other. But this folder is auto-populating in the project. And for that reason, when I open the project, all those spec libraries are loaded into memory and they nicely find each other and run. There is another way to do the relinking. There was a presentation on a GLA summit called Dependency Redemption by Composed CI. And they had a nice tool that solved a bit of what I was also looking for. It was actually one of the presentations that gave us the idea, and we tried their tool, but it relied heavily on the G package manager. But we had a look at the tool, and what it does, it lists all the dependencies, sorts them, and then adds them to an empty project, starting with the lowest dependency first, the one without dependencies, and then building to the top of the tree. Then saves all and deletes the temporary project. I'll send this presentation to Chris, and he can provide it to all of you. There are links in the PDF, and then you can find the tool. So there is a way to relink if you really want to install source code, but we decided to go for packed libraries. Now a bit about the existing package managers. How many of you use reuse code? Maybe Chris can help me a bit with hands.
Anybody? Yeah, Tom's putting his hand up. We've got one. Yeah. Everybody reuses code somehow, right? But maybe officially through packages.
Yeah. Well, at Intersoft, we had like 120 repos with reuse stuff. And who uses the VI package manager? Yeah, I think Tom does, but
yeah, we've got 4 or 5.
Yeah. And somebody using NI package manager?
We use that a little bit. 1 or 2.
Yeah, that's a general feeling that I had a little bit less. And yeah, G package manager, it's less known, and I don't think it's actively supported anymore.
Yeah, nobody in the room.
No, yeah, it doesn't install with LabVIEW, and on the LabVIEW wiki, there's a nice comparison table with more than just this, but well, the thing about VI package manager is that not all functionality is free, but okay. The nice thing about VI package manager is it creates palettes. That's always nice to have. But the only one that had a scope of installation per project was the G package manager. We had a look at that one, but it wasn't pretty straightforward to host your own G packages. So yeah, it was a bit of a hassle to get started with, and maybe it could have been done that way, but it was pretty hard. Now I'm still, especially with my new job, I got a clean sheet to start on, and I'm still wondering which way to go now. So maybe a bit on that later. So this is always a question that I'm asking, because now I'm looking into an NI package manager again, can do a bit more than I thought. But basically at that time, the comparison that I made was an NI package manager versus VI package manager. And as I understood it, an NI package manager is great to install, update, repair, remove NI software, or distribute deployed applications. And for the VI package manager, it's LabVIEW add-ons, libraries, reuse code, some development tools. There's the tools network, the JKI package network. So that was more like distributing reuse code, small libraries, instead of applications or software. I've come to realize that that isn't entirely true, because you can also perfectly use the NI package manager to install PPLs or whatever, but things are not yet, none of them is project based, not yet. So what kind of processes did we test? Well, first of all, you can copy your source code from your reuse into your new project, but that isn't the best way to do it. You can also distribute it using zip files. Actually, a little bit what JKI does at the background. with some manifest file in it. And then there was a great presentation at the first GDevCon from Greg Payne about Git submodules. We tried that. It works well. So if you're into Git and want to use your reuse code as Git submodules, that's perfectly fine. But not everybody was a Git expert or even knew enough about Git, and we ran into some problems with repos, and it was not user-friendly enough to us. And then, as I mentioned before, there was the dependency redemption presentation. It took on a little bit the same problem as we had, and it gave us a lot of inspiration. But yeah, we were also struggling. We were trying to create our own proprietary tool to do something like that. So that didn't get us a lot farther. And then, of course, there are existing package managers, especially then JKI. Around that time, JKI announced LabVIEW virtual environments. There will be something called Project Dragon in the future. They even had a beta for a while. I had a look at it. Looks very nice, but it isn't yet released. So I'm still waiting a bit on that one to fully compare. And then we had a bi-weekly software engineering meeting with other teams, and one of my C++ colleagues told me, why don't you try Conan? And my question was, what is Conan? Well, Conan is an open source package manager for C++, and it can handle binaries. So great, we got a package manager, and we can handle our PPL files. It's once you have Python installed, and nowadays I think almost everybody has Python installed, so it's pretty easy to install with pip install Conan. It has a very good online documentation, especially for an open source project. It's very, very well documented. It's a decentralized package manager, so you can host the packages on your own server, but it stores them in the local cache, and you can upload them to the remote server. Somebody else can then download them again. It's a bit like the same caching process that VIPM also uses. And another big advantage we had was it's already used within Intersoft Electronics. Some colleagues knew how to use it, how to configure it. I just had to do all the special sauce for LabVIEW. And they also have a great mascot. He's called Conan the Frogarian, and you don't want to mess with him. And it started as an open source project. I did speak to one of the inventors. He's from Spain, and he teaches at the university, I think. And he also already used LabVIEW, so that was very nice. And a couple of years ago, it was acquired by a company called JFrog. And they really support it as an open source tool, but with a lot of more company features and marketing and documentation and stuff like that. So now the first demo I'm going to do is, let me show, if you just have Conan installed and you type Conan Frogarian, you get a ASCII of the Frogarian. So the first test to do when you install Conan is show this guy. Now, how do you use Conan after you've installed it? Each repository must contain a Conan file.py, and that contains all your requirements. It's just a list of dependencies, and it contains or it refers to which extension class or which to use or which scripts to override. So that special LabVIEW source that I created was an extension class in Python, so like a child class of the native Conan class, and all my Conan file scripts inherit from that one. So for LabVIEW, they override some functionality in Conan. You can run it on the command line, and each command will execute a list of several methods. Now, here's an example of the Conan file. This is for the A library, like I showed you before. This one requires the C library version 0.x, which is the highest version it can find, starting with a major 0. And it requires my LabVIEW extension, and it actually extends the LabVIEW extension class within the LabVIEW extension package. All Conan files look like this, except the requires can be a list of a lot of dependencies. And it also needs a git URL to the repo, and I'll show you why in a moment. So the user only needs to know 3 commands. It's Conan create, which will create a package from within the current repository. Conan install, which will install your dependencies in your current repository. Or Conan upload, which will upload certain packages to your remote server. If we do a Conan create, it will execute these methods. So first it will set the name, and the green ones are the ones that I didn't override for LabVIEW. Set name, I just look up the name of the LabVIEW project file in the repository, and that'll be the name of the package. I'll set the version. To do that, I use the tag in Git, but I'll show you later how we calculate that version. Then Conan looks to the requirements, calculates the package ID, sets system requirements, all default Conan stuff. And then there is source. It will clone the repo into the local cache folder /source. Maybe I can show you such a. So see users Conan. There's a data folder, and for example, the C library. I had that one already built. It's the C library version, user, and then there's a channel, which is stable or release or testing. And then there's a source folder, and there it clones the Git repo. Then it imports, which actually installs all the requirements listed in the Conan file. So what it will do is it will create a support folder here, if necessary, and then put all the dependencies in there. Then it will build, and this runs a build script, all the build scripts in our LabVIEW project using GCLI. So there's a GCLI operation called LabVIEW build that will set the version number and then build it. And then it will package, it will take the output of the build. So it will build it to a build directory, build folder, and the package will take the content of that folder and put it in the package libs. So this is the longest process, but it's all small steps creating a package. So it actually builds the pack library and puts it in what Conan calls a package. And we added some additional things like setting our own version number automatically. If the Git branch is not master, it will enable debugging. Otherwise, it will disable debugging. Now, on the version number, what we do is we get the latest tag from Git. It's always major.minor.fix. Just get the latest version, latest tag. And we count the total number of commits until the current. So with a git ref list count, you get the first commit, the current commit, and that's the total number of commits. So every commit has a different build number. So every build is unique. And just by knowing the build number, we know which commit was used to build this package. Now, if we're on the master branch, we're gonna create a release and our version number is just XYZ build number. In any other branch, we are developing from the previous release and we assume that it's a fix increment. So we increment the fix by 1. The next command is Conan install. This is mostly used by people not packaging. So people working on projects and consuming the packages and the dependencies. What they usually do is they clone a Git repo, and in that repo, they run the Conan install dot command. That dot means the Conan file.py in the current directory. You can also specify a path, but if the Conan file is in your current working directory, it's okay to just Conan install dot. It will deploy the packages. It looks into that Conan file, lists all requirements and also requirements of requirements. And then it will copy from their cache package libraries to the support folder. And I'll show you how it's done in later. And then when you, oh, that's not dot dot dot. That's not the command. That's a bit more complicated. But when you created a package, it's already in your local cache. But for deploying it and sharing it with colleagues, you can also upload it to a remote server. And Conan supports Artifactory very well because that's also from JFrog, but it also supports GitLab package registry. Now, we already had an Artifactory repository, so we went for Artifactory. Artifactory also has a community edition, which is free, and the only limitation there is it only supports C, C++, and Conan packages. But that's fine. We're only doing Conan packages, not Maven or Python or whatever. So for this, we can perfectly use the community edition. Now, if we upload it, it's also known in the Artifactory repository. Now, what happens if we do a Conan install? If the install doesn't find the package in the local cache, it will try to get it from the remote. And if it only finds a recipe, which means a Conan file with some manifest, it will build it. But for that's more C++ stuff, because the builder is integrated in Conan and not for LabVIEW. So, but it can build it while installing. So it only needs to know the recipe. Now, some pros and cons. We were looking for per project dependencies with source code control. And that's what it does. It installs in the project. There's a Conan file. If all we do within a project is upgrade to a different version of a package, we don't have to change our code. We just have to change the Conan file, a version number or whatever, commit it. It's a new commit. It's a new build of the project. So there is a clear difference between the previous, from the previous commit and the current one. And the difference is if you use the defer tool in Git, you see it's only that Conan file, and it's very clear because it's text-based. It's that dependency with a version number that changed. At Intersoft now, more departments use the same workflow. It was free, open source. It's very good documentation, and it's pretty easy to use. Drawbacks, no nice UI. As LabVIEW developers, we are used to have like VI package manager, which has a nice user interface, or this is all command line based. It's not the default way of working in LabVIEW, and it's also not integrated in the IDE, or not. Well, at the time I did this presentation, first time, I still had the intention of doing some small integration, but I'm not sure. And you can only do your own internal reuse code, because there's no community like the VIPM tools network or whatever. It's what you host on your server. Now, another thing that I added to these slides is what about Project Dragon? JKI said, but Tom might tell a bit more about this. I don't know. At that time, it was set to be released in this latest release of LabVIEW that we have now, but it's not in there yet. It's about managing virtual environments. I had a look at the beta. It looks very nice. And they also announced it at the latest GDevCon. So it looks nice, and it probably can also solve all these problems if you buy the Pro version. So that's about it. Are there any questions before I go to the demo?
Not in the room here, Stefan.
Okay. So I'll try to show something with the demo, but I see that my Artifactory just crashed a bit. So I'll try to restart that while we work on the rest. Now, as you can see here, I did this in LabVIEW Community Edition. I created a Conan extension, which is already known. So if I go to my command line, Conan search will show. Let's see. We want to do this concept first, because otherwise. So now Conan knows the extension class. Might be interesting as well. This is my extension class. So for example, there are a lot of general functions. And I'll find the project name, set my version. So if anybody is interested, this is Python or Python-like code. I'm always happy to explain a bit about this. Now, let's start with the lowest dependency, so C. This is just a very small project, and all it contains, this is a library, proof of concept like library C, and it gets version, which just reads the version name from the packed library, the version number from the packed library. It also contains this Conan file.py, which says it requires the LabVIEW extension, it extends this class, and it's got a Git URL. And in the past they were on Intersoft's, but now the proof of concept is also on my GitHub. It's public. So now when I go to the command line here, I can do a Conan create. This. It will calculate the version number and it will start building. It uses, as you can see here, GCLI, but some parameters. Finish building. So now it's here. We'll do a Conan search. Now there's also the library C here. Now that's the first thing. I'm not sure whether we can have a look at Artifactory. Yes. So yeah, Artifactory looks is a repository like Git, but it's intended for binaries. So Git is not very well with handling binaries, but this one is made to handle artifacts, build artifacts, executables, DLLs, binary files. So when I look here, Conan local, this user, there's library C, this one. We didn't do the upload, but I did this in the past, so it's in there. And then it contains a package, this package. You can, at Intersoft, we also used it to store our executables and stuff like that, installers. So then you have general packages in Artifactory. But these Conan packages have their own hierarchy on the repo manager. Now, if I go to, I want to work on library A, and suppose I just cloned this from Git, from my repo. This is actually what I get when I do a clone from my GitHub. This is a fork. I cloned it, nothing changed yet. I can open the project. But remember, A had a dependency to C. So I'm missing something in the support folder. It says I'm missing get version C. Stop. Oh, close. So all I have to do now is go to the command line. Go all. And it says I copied one file to the support folder. There's my C in the correct version. So now when I load A, there is C. I get version A, which now can also use get version C. It's a very simple example, but was to get the dependencies in there. And now we can do a Conan create A, and it's building A. One important thing is that it's not building A here in my working directory, it's building A in the cache directory. So here, this one, get the source, and it's building over here. And now let's do the same for B. I don't have to do the install either because it doesn't matter if I install it here. I can just immediately do the create because it will install the dependencies in the cache where it needs it. Oh yeah. The Conan file of A or B looks like this. So there's the requires C. And all the rest is the same. And then I also, so now it's built on search. So it has A, B, and C and the extension. Now, when I create a project that uses both A and B, I need a file, Conan file, that says I need A and I need B. This doesn't have a Git URL because I'm not gonna create a package from this. This is actually an application that uses these dependencies, and we're gonna build that in another way, but not, so the Conan file doesn't need the Git URL. So if I do Conan install, it will copy 3 files. We get a support, put all 3 of them here. And I can run my Conan test. So it will get version using library A, get version using library B, and they both get the version of C. So it says we have A version 0012, C 0014, and now B also this one. An additional nice thing that you can get from Conan is such a HTML file that shows your dependencies. There are commands to create such a file, and that's nice in bigger projects with a lot of dependencies. You can see how things are related, and it's dynamic, so also very nice. And now maybe one last thing. If I take C, I go to its fork. You notice that we built it version 0014. So that means my latest tag was this one. 1, 2, 3, 4 is my build number, and the branch is called main and not master. So that was my mistake. Otherwise, it would have been 000. So that's artifactory. Well, I think that's it. If you have any questions, let me know. Or if somebody wants to dive deeper into it, just give me a mail or send me a message.
Thanks, Stefan. That was awesome. Any questions in the room or on Teams? Good. Notice there's a bit of chat in the Teams chat, but I think that's going to be followed up by Tom's presentation up next. So, yeah, thanks very much, Stefan, and give you a quick round of applause and appreciate you coming along.